Okay. So let's see. Where did we? Did I give you an assignment for today?
No.
Where did we leave off right at the end last time? What was?
Were we just finishing up getting shared memory work, or did we actually get that working where we're accessing it right now?
That's a good question.
Because I don't think we set up the semaphore to block it yet.
We did.
Did we?
Oh, we.
Oh no, you did. Yeah, you did. But
All right. So let's walk through this real quick. Here's our server. Am I recording yet? So here's our server. We get. So forever, our server listens, accepts an incoming connection. Here's our semaphore waiting. Now let's look at our clients here. I think we have some compile errors. That's the problem. It dealt with these guys up here because I was trying to make Max clients. I made these global, which is causing our problem currently. But let's just get ourselves logically back where we're supposed to be. So assuming our clients array gets set up correctly, both clients and number of connected clients should both be shared memory based, right? Assuming we get past the compilers, those guys should both be based on shared memory. And the reason we did that is so that we'd have access to it in child stuff. That's why we made them globals. Okay, so we block, unblock here with our semaphore. Spawn off a child if the PID is equal to 0. Is Abe not here today? No Abe. And no Haxton?
Well, he's never here.
Oh, yeah, that's.
He wasn't at home.
I don't know.
He's in the hospital again.
Who is?
Paxton.
Haxton. And who else is missing?
Was that his excuse?
Why were you talking about him? His first name is Abe.
Pebbles in here.
Wait, he's in this class too?
Apparently.
Sam's not here.
All right. Oh yeah, no Sam either.
We should just cancel class today.
Oh no, I'm debating quiz.
Just write your name on it one.
Mhm.
Free quiz.
So what?
Who is the best character?
Free
in
quiz?
Seinfeld?
Yeah?
I'm debating.
Let's stick it to Haxton, you know?
What's up?
I said, really stick it to Haxton, you know?
Yeah.
Yeah, I'm sure he'll really care.
What's this?
Yeah, make it worth double. They don't care, yeah.
I don't care anymore.
All right. All right. So let's keep cooking. So assuming the shared memory works, we spawn off a child. We do child stuff. We should send a message from the child to the parent, or from the child process to the connected client. We should then receive the message from our client right here. The message we receive has a maximum size of 2,000, so that's 2 megabytes-ish. Or 2 kilobytes-ish, rather. So then we have our reply from the server, and then we're going to broadcast this out to what should be everybody, including ourselves. All right, so once this broadcast goes through, it grabs our clients from our shared memory. Actually, with that in mind, it also gets our number of connected clients from that. So with that in mind, those guys don't need to be global. That could fix our issue. So that means we can take, are they based on, we only need that max when they're created. So with that in mind, we can actually move these 3 back down into main. Oh, we had them in main. All right, so we'll create it once here. Well, that's just us getting it in main that we had. Okay, so this is create our shared memory, right? And then this is link to shared mem. So this gets our clients. Oh, no. That's why these guys were. So we need int client ID needs to be up there, and int number of connections ID needs to be up there. Yeah, here's the issue. We'll make both of these guys global, but we'll set them inside of our main. So we'll set the client's ID, the number of connected clients ID. This is an integer that'll be shared among all connected parent or connected or child processes. Then we'll go ahead and get our two shared memory things, be able to do things down there, and similarly down here, we'll be able to connect to our and broadcast our shared memory. Okay, I think this should fix it. All right. Client's ID, first use. Oh, it's called client's ID. That's why I copied and pasted the other one. Okay, undefined reference to seminit, semwait. Okay, did we not, man, seminit is inside of semaphore.h. Did we not include that? I thought we included it last time. Didn't somebody say, hey, did you include that?
Yeah, I'm pretty sure.
Did I spell it? No, looks like I spelled it right.
Oh, it wants you to. It makes you do a special addition when you're compiling it.
Oh, I have to do that shouldn't be right.
It made me do some linker thing when I was compiling it.
That was at the like dash p thread behind it.
Yeah.
Oh, link with dash p thread.
Yeah.
There you go.
I can't remember what it was
You
called.
just tack that onto the.
Yeah, I got you. Alright, so now we should be good for the server. That guy's listening, and the client should just be fine right now, right? The client tries to connect. Gets the server reply. Receives a message, prints out the message, then sends a message back. But right now, when he sends that message back, it's going to get broadcast to everybody. Okay. So there's our GCC there. We are connected. All right, hold on. So here's our we are connected. Then we're going to receive from the server. And this guy says reply received, but the server didn't actually send anything.
Yeah.
Huh?
Doesn't it still send the like initial?
Well, the server's still, it says problem with binding. Oh, so the server didn't actually start up right. Let's try it again. Okay, well that's new. It's our setup down here. Here's our problem with binding. Is it our port? We're on port 3000. Let's just try to put it on port 4000. Yeah, 3000 must have been taken or blocked or something. So we'll just change this to port 4000. We're dealing with a really like high-end chat server. There we go. Yo from the child. Do you? Let's see. Hold on. Oh, that's because we broadcast back to ourselves. So reply received. Hello from the child. Do you have candy? And then we received another reply. Yo from the child. Do you have candy? We'll go ahead and connect with this dude. And it looks like we need to move into chat with this. To client ./a.out. Yo, blah, blah, blah. Go back in here. We should have another one. And we do. So now we seem to be broadcasting to everybody over shared memory and all that good jazz. Are we reading anything in from the client yet? Okay, so that's where we've left off. Have you guys had to read anything in yet? So we haven't looked at scanf or anything? Okay, so let's do that. Actually, we could do a getS, since we're just reading in a string. That'll be a fun one. So there's two things we're going to learn today. We're going to learn how to read stuff in from the user. We're going to learn how to do string compares. And we're going to, actually that's probably going to be good enough. Because ultimately what your homework assignment is going to be, and you'll have some extra time to do it. We won't have class on Monday. My wife is having some non-major, just outpatient surgery. She just needs a ride. So, so I won't be able to be here because she's going to be wobbly.
You gonna take videos so we can learn?
Of course. Yeah, so I'll make the homework assignment due on Wednesday. But as I offered before, if you want to do the hackathon tomorrow, I think you can still sign up. You are excused from this assignment. So you get a free 100% on this assignment if you sign up and do the hackathon. Otherwise, you have to do the impossible assignment.
I'm calling in work.
Okay. But it's a trade-off. Hackathon's an 8-hour commitment. Maybe the assignment's going to take you less than 8 hours. Who knows?
What's the assignment?
I just told you. Oh, did I actually finish telling you?
No, you didn't.
Yeah. Well, I told you it's impossible. If you're not going to be able to do it anyways, does it matter what it is?
I mean,
You said things are impossible before.
yeah.
Oh, that's true. Well, I gave you the merge sort. Oh. You skipped presentations yesterday.
Yeah.
What a great reply.
Yeah.
This is true.
Total bonus points for that. Yep. Totally.
Happened.
What were those?
Well, it wasn't graded anyways, but I assume you're doing okay in your project. You just decided not to present.
No.
All right, perfect. A couple other people who were there also decided not to present while they were standing up here presenting.
Wow.
I have changed my mind.
No. They might as well not have presented, is what I'm saying. They just babbled on about stuff.
Paxton stood up though.
Paxton did stand up.
Weird.
And then, oh, you were you there?
No.
Weren't you in the class?
No.
Oh,
What the heck, Randy? Should have been there.
oh yeah, because you should have been there because we had a video game that Sam had a very questionable enemy running around. Here, we should pause this real quick. All right, so we got. All right. Yeah. So in any case, the homework assignment is going to be. We're going to learn how to read stuff in from the user right now and print some stuff back out. It's going to allow the client to send a message. So type something in, then it gets broadcast to everybody else. So that's just going to be a little addition to what we have now, right? We already have the client sending a message. We already have the server broadcasting that message. So now we just need to change the source of the message on the client to come from the user's keyboard instead of our hard-coded hello from the child, right? Or our hard-coded yo-yo, rather, is this one. Make sense? So we need to be able to read in from the keyboard. But the other part of the assignment is going to be to send private messages. That is to say that from the client side, I should be able to type in the, and for us, we're going to do it a little bit ghetto. So on the server, we're going to, when somebody connects, we're going to rebroadcast the whole list of connected file descriptors. That way you know the unique ID of each client. That's their username, since we don't have authentication and stuff. So you can, so for instance, let's say that Yenter is connected and he's, Chastity, sorry, thank you. Thank you. I appreciate that. Start for the day. Oh, I came up with a nickname for you.
Me, Curse.
Yes, Curcio. I have no idea why this fits. I saw this word yesterday, and I immediately thought about you, and I have no idea. Okay.
Thanks for thinking about me.
Yeah, and it felt creepy. Okay, it's cinnamon with an S.
Am I a stripper?
I have no idea. I have.
Were you looking at strippers?
I don't even remember where I saw this. I swear.
Strip club.
But the very first thing that popped up was in my mind was Curcio. So
I'm glad you think of me like that.
so
Do you have to like really put emphasis on the cinnamon? Is that it then?
cinnamon.
It's not cinnamon.
Right.
Cinnamon.
Yeah, so we got Chastity, we got Cinnamon. So yeah, that's bound to stick, I think. All right. Plus you got a couple of years left, so that's really gonna.
We'll be around.
Yep. All right. So in any case, the client will be able to type something in. We'll then send it to the server. Server will then broadcast it to everybody. Then we're going to also have the ability to send a private message. So if I want to send a message to Chastity and his client ID is 4, let's say, and the only reason I would know that is because I happen to have access to the list of server people, and it's given me a list of everybody connected. So it's a little bit of a ghetto direct message. But I'm going to type in 2 different commands. Unless we get far enough today to split strings. Actually, no, we can do it because one of the things is going to be basically the equivalent of index of. We'll be looking at the string library, so we'll do it as one command. So I should be able to do send for hello. And that should only show up on Chastity's screen. Just the person whose client file descriptor is 4. That makes sense? So we're going to add the ability for direct messages. So with that in mind, let's look at strings.h and see. And we can look at some of the functions that this guy supports. So this is the string library. So put yourself into kind of Java mode for a few minutes so we can make kind of the comparison with Java, but also remember that how a lot of these functions work. Since this is not an object-oriented language, functions take in the strings. You know, they're not instant. We don't have a difference between instance methods and class methods. Effectively in C, everything is a class method in our mentality. So we have to give it all the inputs that it's going to work on. Okay? So here's some struct stuff. So here's some functions. That's not going to be what we need. That's not going to be. Okay, so here's one. This is for string concatenation. So this appends the string pointed to by source to the end of the string pointed to by destination. So let's kind of test a few of these through a sample application. So you guys have access to that. So we'll go in here and let's go ahead and just create a new file. And we'll call this guy string test.c. All right, and we will, actually let's just steal some of our things from this guy. I'm going to take most of these out, but that'll just be quicker to do it this way. Might as well steal the main as well. All right, so don't need that, don't need that. Probably don't need that, but we'll leave it up there for now. Okay, so let's go ahead and create a couple of strings. So we'll have char pointer s is equal to hello. Char pointer s2 is equal to world. All right, and then here's one of our functions. So it's string cat this guy, or strcat, this guy takes in a source and a destination, and it appends source to the end of destination. Takes in 2 char pointers and ultimately returns a new string. Okay? Oh. So we'll say char pointer s3 is equal to strcat s comma s2. And then we'll do a put s s3. Yeah, that should work okay. So this should give us hello world all glued together if this works the way it's supposed to work. All right, so let's just go back here. There's our string test. Oh, memory. Memories. Okay, so let's see. So S is the, I wonder if we could pull it off by giving it the address here. Nope. No. So we'll go ahead and malloc. Actually, let's see if we could use one of the string libraries for our builder. Alright, this was dumb, but so we'll say char s is equal to malloc. Now, because we're going to need to be able to read it in from our, let's see, C strings. Alright, let's keep typing. Alright. Yeah, see, we don't want to build it like that.
I have plenty of C strings.
Thank you.
Thanks, Cinnamon.
Yeah, see, this will create an array. I guess that would be a maximum size. So we can do that. That'll be okay. That'll be the easiest way to. So we'll say int max size is equal to, I'll just say 1,000 for this, and we'll say char pointer is malloc max size times size of char. We'll do the same thing for this guy. And then we'll say s is equal to hello, and since it's a string, it'll be terminated with a \0. s2 is equal to world. So then we should be able to concatenate them, and these are taken in pointers, so we're okay there, giving us s3, and we should be able to do a put s on s3, because even though s3, well, let's say we were doing a put s on s, which we know s is actually sitting in a chunk of memory with a maximum size of 1,000 bytes. Hello obviously doesn't take up 1,000 bytes, so the way put s works is it walks through this guy as if it's a character array until it hits this invisible character here, \0, which is the Unix string termination character. All right.
Is S3 going to be mad that you didn't allocate memory for it?
No, because it is being allocated by string copy.
Okay.
Or string cat, rather, in this case. So string cat does that magic internally. Well, at least it should be. Well, I guess we can try to allocate memory for it, but it shouldn't be that way. So we'll do that, but we'll be tyrants and not free the memory. There, oh, hold on.
You didn't put an equal sign after S3.
Oh, well, now what's this guy really complaining about? Maybe it's on put S. Okay, we're okay there. Let's set our first string. We might need to do a string copy in. Alright, now it's okay with that. Should be okay with that, so it looks like, well, let's go ahead and get us to there. I think we should be good to there. Alright, so it is string cat. Takes an S and S2, concatenates them together. Yeah. Alright, so let's look at man cat. Okay, well, our string should be long enough to let me not do this for a second, and let's just do a put S on S to make sure this is doing what I think it should be doing. Okay, good. So that's the \0 termination. So string cat takes in the string pointing to by source. Oh, is it because that guy needs to be a constant? So let me try that. Let's call string cat here. On world. We'll give it a constant. And then we'll print out S3.
After you call that, is S2 and S3 equal to each other?
No, it does not change S2.
Or sorry, just S. Because it says that S2 is then appended to S.
Oh, wait, you're right, actually.
And it even said
But
that
this guy returns a char array. So what does this say it returns?
It says it returns the pointer to destination. Returns the pointer to the thing that you passed it.
That's weird. String cat.
Or at least that's what I thought it said.
Overriding the terminating null at the end of dest, and then adds a terminating null byte. The stream agent, blah blah blah. Yeah, so it creates. It's modifying dest. Yeah, so you don't even need to use the value it returns if you don't want. Returns a pointer to the resulting string dest. So here's dest, current length of dest, and now it's just adding on to dest, so it's modifying, it's adding on to the end of dest. That's why we get the length of dest. And then it's tacking on the backslash 0 at the end. Yeah, so it actually has not changed. So chances are in this case, I should print out S. For ours, we don't actually need to. Why? I still maintain we should be able to do this. We shouldn't have to alloc for this stuff. Let's prove that. Okay, good there. All right, and the first parameter is the destination, and it's a char pointer, and we have a char pointer. The second one is a const char pointer, which is, I think that's just saying it's not changing. I'm going to take out some of these extra includes. I think we just need string h and standard IOH. Oh, actually, we'll need standard lib, I think, for the put s. Plus the declaration of built-in function. Okay. So there's our string h. Does it say we need to link this guy with anything? Doesn't say you have to.
Does C not like it if you're just using a bunch of headers that you're not really using?
I took all those headers out.
I was wondering, that's why.
It shouldn't. I was just wondering if two of the headers had two functions that matched, and they were conflicting with each other, and it was actually calling a different version of strcat. Why would that? Let's try a different string function. Str searches the first occurrence of the character, the string, so that returns a. Let's try string compare. He's going to return an int 0 if they're the same. Okay, well that one seemed to work. So if I print out val, this should give us a, actually val's not a string, so it should die on us. I'll have to use a printf, I think. Yeah. Printf %d backslash n val. So this should give us a, I think probably a -1, but something other than 0 for string compare. Actually, hello should come before world, so it'll give us a value that's smaller, so it should be less than 0. This is equivalent to compare to in Java, I believe. Yep, so -15, something less than 0. So we know hello comes before in the alphabet world. But if I pass it S2 here, it's going to give us a 0, because they're the same. So when string compare returns a 0, that means they're equal to each other. So in your homework assignment, you're going to be doing a string compare for, you know, maybe you say MSG, message. So you'll when you piece apart your string, you'll be doing, well, you'll have to walk through your string and concatenate on the stuff, assuming you concatenate working. But you'll have to check to see if what you've received is message. It's a string pointed to by source to destination. Yeah, so this is the string searches for a specific portion of a string for a value. So for instance, if we have, we're connecting this back to the homework assignment, if we have a string like this, message for hello, we can say string in S for MSG, and it should give us our it should give us a 0 because it starts at bucket 0. And then we'll print out val. Oop. Integer from pointer without cast. What does this guy return? Oh, it's returning a, what's interesting, it says it's returning a char pointer, string. It returns a pointer to the beginning of the substring where it lives. So this will actually give us a string starting at where it starts. That's actually convenient. So we can do this then. Okay, we'll actually just do a put s on this for right now. Comment out this, get rid of this. All right, so this is going to, this should print out the entire string since this is technically going to give us a, it'll find it at bucket 0, so it's going to give us a pointer to the beginning of the substring that has message in it, which is the beginning of it. But since we're printing out the entire string, that \0 is still here. So when we run this now, there's our message for hello, but to prove that it gives you the substring, we'll throw something in front of it, LOL space. So now it's still going to say message for hello. there's a message for hello, proving that it got us to the place where that guy lives. Let's see, here's our tokenizer, break string into a series of tokens.
If it doesn't,
Go ahead, I'm
doesn't
sorry.
find the substring, does it return -1? Or
It would probably return a pointer to the end of it. We can test that real quick. So I'm guessing it will basically get the empty string. So you probably need to check to make sure it's not null. Must return a null value. Okay. So let's bounce that back. String tokenizer will split something, so let's go ahead and split this on string toke. We'll split this guy on spaces, except this is not going to, this is going to be a char pointer parts is equal to this. All right, and then we can, in this case, we know there will be 4 parts. So, let's see, does this guy take in a... It's actually a tough one because we don't necessarily know how many parts there's going to be. Okay, so it's going to actually be filled up with things until you finally hit a null pointer. So that char array that it returns, you're not going to know how many elements are in there. You're going to have to search for null. So this guy ultimately is going to have things in it. We know it's going to be 4, so we can say for anti 0, for that. I is less than 4, I plus plus. We'll do a print f %s backslash n parts at bucket I. So this should give us the individual parts from that guy. What's it complaining about?
it's giving you
Parts is a char. Well, that's a char pointer. Is that what that guy returns? All right. Well, in any case, there's some examples of how the string library works. I really don't have a great explanation on concatenation. Hopefully you won't have to use it, but yeah, that's just weird. But yeah, here's an example of this. So as long as so this gives you a, through all the tokens, so string toke. Oh, yes, you can call this guy multiple times. So string toke, you pass it a string and it just keeps giving you the next token, breaking down your string, just like Java string tokenizer, where you run out of delimiters. So this breaks down a string. All right, so I'll give you a link to this string library in the homework. But like I said, if you want to avoid the homework assignment, you can sign up for the hackathon, but do that like in the next 20 minutes because I'm putting all the teams together.
Can I start?
Not even fair.
Nope.
Not even fair.
Which part?
Homework for the hackathon.